Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Here is Mubashir Riaz, and today we are going to discuss our next topic of chapter number 5, which is centripetal force. So, in this topic, we will discuss about the centripetal force, its mathematical form, and the factors upon which this centripetal force depends. So, what is centripetal force? Centripetal force is the force which forces the body to move in a circle. It's called centripetal force. कि जो एक ऑब्जेक्ट को सर्कल में घूमने पर मजबूर करे, उस फोर्स को सेंट्रीपिटल फोर्स बोला जा सकता है. The force which forces the body to move in a circle is called centripetal force. The force which changes the straight line path into a curved path is also called centripetal force. कि ये फोर्स एक स्ट्रेट लाइन में मूव करते हुए ऑब्जेक्ट के स्ट्रेट लाइन पाथ को कर्व्ड पाथ में चेंज करने की सलाहियत रखती है. So this force is called centripetal force. For example, when object is following a circular path, its direction of motion is always along the tangent to the circle at each and every point. आप नोट कर सकते हो कि जो डायरेक्शन ऑफ वेलोसिटी है, जिसको हम लीनियर वेलोसिटी या जिसको टेंजेंशियल वेलोसिटी भी कहा जाता है, it is always directed along the tangent to the circle. But the force required to keep that object in the circular path is always directed towards the center of circle. So this force is required to keep the object in the circular path. For example, जैसे अगर आप एक स्ट्रिंग के एंड पे एक पत्थर को बांध कर घुमा रहे हैं, तो आपको फोर्स अपनी तरफ अप्लाई करनी पड़ेगी, टुवर्ड्स द सेंटर ऑफ सर्कल अप्लाई करनी पड़ेगी. अगर आप एक लम्हे के लिए भी ढील दे देते हैं या रस्सी टूट जाती है, तो वो जो पत्थर रस्सी के साथ अटैच किया गया है, वो एक लम्हे के लिए भी सर्कुलर पाथ में नहीं रहेगा, वो वहां से अलोंग टेंजेंट शूट कर जाएगा. That's why this force is required to keep the object in the circular path, which is called centripetal force, and the direction of centripetal force is always towards the center of circle. To drive now there is centripetal acceleration. Centripetal acceleration can be defined as the acceleration which is produced due to centripetal force is called centripetal acceleration. To drive the expression for the centripetal force, let me consider an arrangement which consists of a body having mass m, which is moving in a circle whose radius is r. So let it moves from point A to point B. Its velocity at point A is v1 and at point B is v2, as shown in this figure. So there is a particle, there is a body whose mass is m, and it is moving in this circle whose radius is represented by r. At point A, its velocity is v1. At point B, its velocity is v2, and this velocity is along the tangent to the circle at that point A and B respectively. Here the magnitude of velocity remains same. यहाँ आपने ये पॉइंट याद रखना है कि when this particle, this body is moving in the circle, then its magnitude of velocity remains same. We can write v1 is equal to v2, so both can be replaced by v. यानी magnitude में change नहीं आ रही. अगर magnitude change नहीं हो रही, तो फिर इसमें acceleration produce कैसे हो सकता है? So this acceleration is actually produced due to change in its direction of motion. आप यहाँ नोट कर सकते हैं कि इसकी जो डायरेक्शन ऑफ मोशन है वो हर लम्हे चेंज होती है, क्योंकि वो अलोंग द टेंजेंट टू द सर्कल हमें मेंशन करनी होगी, और वो हर लम्हे चेंज हो रही है. सो एक्सेलरेशन इज प्रोड्यूस्ड ओनली ड्यू टू चेंज इन इट्स डायरेक्शन ऑफ मोशन. सो दैट प्रोड्यूस्ड acceleration is equal to rate of change of velocity, where delta v is change in velocity, delta t is the time taken to move from point A to point B, and this time taken is equal to s over v, where s is the distance moved from A to B and v is the magnitude of velocity, which is v. So delta t is equal to s over v. By putting the value of delta t in this equation, acceleration becomes equal to delta v divided by s over v. Finally, AC becomes equal to delta V into V over S. So this is equation number 1. यहाँ ये इसका डिस्टेंस कवर्ड होगा फ्रॉम A to B, जिसको S से हम रिप्रेजेंट कर रहे हैं. Now consider a triangle PQR. This is another triangle PQ and R, whose one side, which is PQ, this one, should be parallel to V1. इसके पैरेलल होनी चाहिए, यानी ये लाइन और दिस साइड PQ should be parallel to each other, and other side, which is PR, should be parallel to V2. This PR, which is vertically upward, should be parallel to this second velocity at point B, V2. यानी इस ट्राइंगल PQR को डिजाइन करते हुए आपने इन दोनों चीजों का ख्याल रखना है कि PQ को V1 के पैरेलल होना चाहिए, PR को V2 के पैरेलल होना चाहिए. Now by comparing both equations, both triangles, OAB, there is first triangle which is OAB, and the other triangle is PQR. This is first triangle O, A and B, and the other triangle is P, Q and R. So in these triangles, OA is equal to OB. Here OA is actually the radius and OB is also radius of the circle, so they are same. Similarly, here PQ is perpendicular to OA. यहाँ आप नोट कर सकते हैं कि जो PQ लाइन है, it is perpendicular to OA. ये हम किस बेस पे कह रहे हैं? Because PQ is parallel to V1 और V1 टेंजेंट के लॉन्ग है, लिहाजा टेंजेंट और रेडियस हमेशा परपेंडिकुलर होते हैं. सो एंगल this side PQ and the side OA, they are right angle to each other. Similarly, PR, this PR is parallel to V1 and V1 is perpendicular to OB, so we can write PR is perpendicular to OB. Hence, these triangles are isosceles triangles. ये जो triangles के बारे में कहा जा रहा है कि these are isosceles triangles, उसकी एक reason और भी है कि this angle theta at this position and this position, they are same. जो एंगल यहाँ बन रहा होगा वही एंगल यहाँ पर भी बनेगा, और इसके लिए आपने एक थ्योरम याद रखना है और उसके मुताबिक एंगल बिटवीन टू लाइंस OA and OB, they are actually two lines. So angle between two lines and angle between their perpendiculars. Here PQ and PR, they are perpendicular on lines OA and OB respectively. So angle between these two lines and angle between their perpendicular is always equal to each other. So that's why these triangles are isosceles triangles. So in these isosceles triangles, the ratio of any two sides will remain same. For example, from this side, QR divided by PQ or PR, because V1 and V2, they have same value. तो आप यहाँ नीचे PQ भी लिख सकते हैं, PR भी लिख सकते हैं, और जो न्यूमरेटर है that is QR. So QR over PQ. In second triangle, this side AB and divided by either OA or OB, because they are radius of circle. यहाँ भी OA भी लिखा जा सकता है, OB भी आप लिख सकते हैं. QR can be replaced by delta V. This is change in velocity. QR replaced by delta V. And PQ can be replaced by V1, and V1 is also equal to V. So this becomes delta V over V. AB, which is arc length from A to B, This is the arc length, and it can be replaced by S. And OA is the radius of circle. So from here, delta V over V is equal to S over R. आप यहाँ से डेल्टा V की वैल्यू को फाइंड कर सकते हैं, एंड डेल्टा V इज इक्वल टू एस वी ओवर आर. ये जो V है ये इस साइड पर मल्टीप्लाई होगा. सो डेल्टा V इज इक्वल टू एस वी ओवर आर. बाय पुटिंग दिस वैल्यू इन इक्वेशन नंबर 1. सो इक्वेशन 1, AC इज इक्वल टू एस वी ओवर आर. यहाँ डेल्टा V था तो वहां आप एस वी ओवर आर यूज करेंगे इंटू V ओवर S. तो S से S कैंसल, then AC becomes equal to V square over R. This is centripetal acceleration, and it is equal to ratio of square of velocity to the radius of circle. So it depends upon the velocity of moving object and the radius of circle. According to Newton's second law of motion, we know that F is equal to ma. Here C for circular motion. So F.Sc is equal to MAC. Centripetal force is equal to mass into centripetal acceleration. So by putting the value of AC, which is equal to V square over R, this is centripetal force becomes mv square over r. So it depends upon the mass of moving object, square of velocity, and radius of circle. So centripetal force depends upon these three factors: mass, square of velocity, and radius of circle. So this is mathematical form of centripetal force in terms of linear velocity or tangential velocity. This one is the linear or tangential velocity. So Fc is equal to mv square over r. In terms of angular velocity, we know that v is equal to r omega. This is relationship between linear velocity and angular velocity. So by putting the value of v in the previous equation, it becomes m r square omega square over r. यहाँ एक r से ये एक r cancel. Then final expression for centripetal force in terms of angular velocity, mr omega square. So this equation can be used if angular velocity of that moving object is given. Then mr omega square is equal to centripetal force of that moving object. So with the help of these two expressions, we can determine the required centripetal force to keep an object in the circular path. And this centripetal force sometimes provided by the gravitational force, sometimes provided by the tension in string or any other medium. For example, moon is revolving around the earth in its particular orbit. So the required centripetal force is provided by the gravitational pull of earth. So this is centripetal force, its mathematical form. Thank you.